Hello and welcome to the Spacewalker live session, in which I will present bridging meshing on OmniAccess Stellar. Bridging meshing is often considered as separated installation in enterprise WLAN deployment and is therefore not thoroughly or properly studied. The purpose of this presentation is to highlight the key design points to consider for a successful bridging meshing installation with the advanced mesh feature of Stellar access point and latest release 4.6.2 of OmniVista. At the agenda side, first, we will see the main use cases, especially for outdoor bridging, the constraints of outdoor installation, as well as indoor multipoint topology. We will review the architecture of Stellar multipoint meshing in release 4.04. OmniVista 4.6.2 and Express Mode support Stellar multipoint meshing. We will detail the meshing configuration with OmniVista and the monitoring of meshing on Stellar. Finally, we will conclude on what to remember about the solution and benefits brought by the solution. The wireless bridge is a most requested use case in enterprise. It is typically an outdoor point-to-point LOS configuration that allows to connect a remote building and to cross a public area where the cabling is not possible. Each AP is managed in bridge mode and routes its radio to the LAN, and the bridge extends the LAN and performs distribution of corporate VLANs on the different Ethernet ports of the bridge access point. On the non-PoE ports, on PSC port to power some PoE equipment, like IP camera, and this without additional PoE injectors. There is no broadcasting or WLAN services for Wi-Fi clients in bridge mode. The installation of a bridge must be planned and rigorous. Imperative use of MIMO antennas with polarization diversity, use of high-gain directional antennas, and a certain height and clearance for the radio link. It is recommended to use the .11ax access point to exploit the RF features of the Wi-Fi 6, as well as using a minimum of 40 MHz channels wide to share the bandwidth of the bridge for the whole VLANs to be carried. As mentioned, an outdoor installation must be planned. As guidance, here is a list of points to consider. The placement of the antenna must take into account possible obstructions like trees or other buildings, and the height must take into account at least 60% of clearance for the Fresnel zone. LOS configuration are preferred. The antennas are aligned, and all the site mounting options should be evaluated. Installation will follow local regulations, as well as civil aviation regulations, in the case of significant height. The channels used are those of DFS bands for outdoor, with the possibility of setting a IERP up to 30 dBm of power. It is necessary to protect the installation and the network from electrical discharges by grounding the installation. The antennas must be equipped with surge arrestors, and mounting kit must always take into account a PoE injectors for outdoor use. A list of PoE injectors supplied with Stellar access point is provided for information. For reference, the table shows different Stellar configurations with antennas and their usages. The expected distance for this type of installations are given in the architecture part. Multipoint outdoor meshing. Omnidirectional antennas are preferred for multipoint meshing, and LOS configuration are possible. And in the case of semi-directional antenna used for the route AP, consider a loss of less of 2 dB at the limit of beam width for the placement of mesh AP. WLAN services are broadcasted to Wi-Fi client in mesh mode. The combination with a bridge configuration is not possible. For each mesh access point, the global traffic capacity of the route mesh is shared between mesh link, mesh APs, and client SSIDs. Then bandwidth is divided by 2 for each SSID traffic. Each AP mesh can broadcast up to 5 SSID for outdoor Wi-Fi clients. Management of each SSID is identical to campus SSID, with support of various VLANs and QoS management for external Wi-Fi clients. VoIP and real-time application are supported in best effort mode only. No roaming between mesh AP, and there is a maximum of 16 mesh AP per mesh configuration. Indoor meshing is generally used for industrial and factory areas. RF requirements for indoor meshing are identical to indoor coverage. SNR of 25 dB or better, and RSSI of at least minus 65 dBm. Maximum distance of 70 meters between APs in .11ac or AX. Use of external and omnidirectional antennas with sufficient gain, for example mounted directly on AP 1322. Patch antenna types are not recommended. It is also possible to benefit from a mesh configuration at home with enterprise-level connectivity in areas where Wi-Fi coverage is desired, including the office for home working. Home meshing is characterized by short distance, allowing high data rate, more speed for recent dual-band and Wi-Fi 6 smartphone, QoS and data rate for TV, gaming, and multimedia broadcast. The use of AP1301 entry-level Wi-Fi 6 completely meets such demand. The route AP is connected to the room router, and the installation of a mesh is as light as possible. Stellar Mesh AP management at home is Express mode. For a review on details, Stellar multipoint mesh architecture consists of a cluster of routers with no cabling between the APs. The mesh link is shared between the different access points and uses dedicated wireless interface. All the traffic is forwarded from or to the AP route, which is the gateway connected to the LAN, and the traffic uses the same channel and the same radio. The bandwidth of the link is shared between the backhaul traffic and the client traffic. This architecture allows a multi-point wireless configuration. In that case, the client traffic can be delivered on both 2.4 GHz and 5 GHz bands, and the automatic transfer of SSIDs existing at route level to the mesh APs. A point-to-point bridge configuration by specializing an AP in bridge mode. The distribution of corporate VLANs over the mesh link. The ability to use Ethernet port of mesh AP to route wired client traffic. By creating a dual route, Stellar multipoint meshing runs in high availability mode, and any mesh AP is connecting to the IP route with the highest RSSI. The auto mesh features broadcast default mesh link on the 2.4 GHz band at the route creation. A Stellar AP in factory mode and which is not connected to the LAN, try to connect first to this link. Advanced WDS mode. Stellar meshing solution is an advanced WDS distribution system. Each AP in the mesh cluster works as an access point in WDS mode and allows transparent Ethernet bridges over the APs with a common broadcast domain and the transport of different VLANs for all devices. VLANs can be VLANs of management or for data traffic, tagged or not tagged. APs switch to the 4 MAC addresses format available in .11 with WDS. A bridge device sends the packet to the LAN device, and the 802.3 frames are relayed via the APs in WDS mode. AP-WDS relay the frame to the device using second MAC source in .11. This mode is available in bridge and multipoint mesh. What about distance for a mesh link in outdoors? The data rate decreases significantly with the distance between the access point of a mesh link. The installation is always a trade-off between the distance and the expected performance for the link. For your reference, the table reports maximum distances in 11AX or AC on the 5 GHz band for main Stellar configuration. The calculation is based on the link budget for each configuration and takes into account pre-pass loss and a system margin of 10 dB minimum, which is a value usually adopted in bridging to take into account the radio fluctuations due to external conditions, as well as a LAN link performance estimation provided by EKO Planner. For very long distances, the use of MIMO antennas available on the market is always a possibility. There must be 5 GHz MIMO compatible, highly directional, and of the grid or parabolic type. What we have seen before is an indication of distance for a given 11AC or 11AX configuration. However, a link survey is mandatory to plan an outdoor mesh installation. It allows simulation and performance estimation, especially on throughput. The EKO Pro 10.4 planning tool allows to simulate the radio propagation for AP's configuration with antenna parameters, including the transmitted power level, radio characteristics, and the selected antenna in MIMO. EKO Pro version 10 includes external antenna and last external Wi-Fi 6 stellar access point. In the example here, we see that the AP1361D 4x4 MIMO running with a shared bandwidth of 80 MHz can provide a 500 megabit per second LAN at the maximum distance for this configuration. A reception at minus 70 dBm and with a SNR of 20 dB is the acceptable limit for a data link. The creation of a mesh group consists in specializing some AP managed in OmniVista, AP per AP, to operate either in a root role or in mesh role. It is recommended to plan a static IP reservation for all AP. It is recommended to create an AP group dedicated to the mesh, in which you have to manage an SSH console at admin level for the maintenance, and also manage a login at admin level for AP web access. We create a RF profile to assign to the AP mesh group. In this case, it is for an external link. We manage a 80 MHz channel wide with a DFS 100 plus list and a maximum transmit power of 21 dBm using the DFS TPC function. We also use Wi-Fi 6 features. We also create the SSIDs to be broadcasted for the clients. In the case of a multi-point, they are assigned to the AP mesh group. We assign the RP profiles and VLANs to be distributed in the machine. The management of a root role is done by editing the IP mesh management and validating the root role and SSID link mesh, radio band, and password. The management of a mesh role, it is a bridge here, is done by editing the IP mesh management and validating the mesh role and the SSID of the mesh link with the radio band and a password. In Express mode, the API UI is accessible from the main page by clicking on the AP of the access point in a cluster. Note, the API UI is also accessible in Enterprise mode by selecting AP from the IP list. At last but not least, Mesh AP must be disconnected from the LAN to be installed on site. It takes a minimum of 4-minute boot to receive their mesh configuration. Monitoring stellar meshing. All metrics for monitoring each mesh AP are accessible via access points consoles. Go to the mesh topology in OmniVista and launch a SSH Telnet console on the AP you want to monitor. To monitor with a shared radio profile, you need to consult the RF profile conf file And for example here, it is the consultation of the settings of the configuration done previously on the root AP. Link quality measurement evaluates the robustness of the mesh link and is based on a received signal and SNR levels. The measure will be done with the following command: lwconfig interface, and the value indicated is OmniAccess Stellar 1, and the minimum recommended is 70 for a mesh link. The data rate indicated is also an evaluation of the speed negotiated between the two nodes. To know the channel used on a given mesh link and a given band, apply the command iwlist number of interface channel. To list all wireless interfaces on an AP in a mesh role, use the command iwconfig alone. Finally, in order to monitor clients connected on a mesh node, monitoring done is the usual monitoring on clients associated with a specific eSSID, with RSSI's data rate, the operated band, and client capability. Use the command iwlist_str with interface ATH01 to monitor associations on the 2.4 GHz band. Use command iwlist_str with interface HTH11 to monitor association on the 5 GHz band.
In conclusion, we have seen how to deploy, how to design and operate a meshing solution on OmniAccess Stellar. We have seen that Stellar is a secure, high available meshing solution which allow to distribute corporate VLANs on mesh link, client SSIDs, and port of the mesh access point. The range of external Stellar access points is mainly used for meshing. We have seen the case of outdoor bridge, which is the most used. These installations are designed to operate outdoors. We have seen constraints to be taken into account for this type of installation. In particular, the distance between AP, which is the first constraint for link performance. RF feature of Stellar Wi-Fi 6 can be used with advantage for this type of coverage. An outdoor WLAN survey is imperative and must be performed to validate the performance of each link. It is imperative to distinguish it from the usual indoor deployment in enterprise. Finally, we have seen simplest configuration in enterprise mode with OmniVista 462, but also in express mode, as well as the monitoring of mesh nodes once placed on site. Keep enjoying your Spacewalker Live event. I am looking forward to interacting with you on this and other topics on the Spacewalker platform. Take care and see you soon.